Graph rate of change of functions. Describe and sketch the rate of change of each of the following functions. We have two functions for you here. First one is the cubic function and the other one is a combination of linear functions. You can pause the video, sketch the graph of rate of change of these functions and then look into my suggestions. Now let's see how to describe and then sketch the rate of change of these functions. Now, if you observe the cubic function shown here, tangent at a point on the graph really gives you rate of change at that point. Let's begin with the very center value. Here, if I draw a tangent, it will be a horizontal line. So it will correspond to a zero value. So rate of change will be zero at the origin. As we move towards the left side, you can see that the tangent here will have a positive slope. As we move more towards the left side, it will still have a positive slope but much higher slope. So what we observe here is as we move towards negative x, the slope becomes more and more. That means the rate at which the y value is changing with respect to x value is much higher as the x value is more negative, right? On the other side, if the x value increases from 0 towards the positive side, then we observe that the slope is still positive as it was earlier, but as we move further away from origin, the tangent becomes steeper and steeper. That is to say that the slope becomes higher positive, right? So the rate of change increases at a much faster rate as we move away from the origin in both the cases, and it remains positive. If you find the values of these tangents, you will get the exact values, and if you sketch the graph, you will get a parabola. So I'm just sketching a parabola for you, and that is how we can get the rate of change of the given function. So the reasoning behind this parabola is that at origin, slope of the tangent is 0, so it goes through the 0, and from the symmetry we can see that as we move away from origin, slope of the tangent increases both sides, correct? And from the symmetry we can sketch a parabola. To get the exact values, it is a good idea to sketch the tangent. For example, this is our tangent at this point, which is, let us say, slightly less than 1, and it looks like that the slope is 1, right? So at this point we can say the value is 1. So this is a scale of 2, so at this point the value is 1, right? So likewise, if you sketch a tangent at other points, for example here, so you can find the slope and get a corresponding value. Joining those, you will get a shape of a parabola, right? So as an exercise, you can do these calculations. But remember, for a cubic function, the rate of change graph will look like a parabola, a quadratic function. You'll observe that whenever we find rate of change of a polynomial function, then it is kind of 1 degree lower, so it follows that kind of pattern. So that is good to know, so that you can connect the points in a way that it looks like more accurate, right? Now let's look into the second function, which is a set of linear functions. Now as we move from left to right, we see that in parts there are straight lines, so that means during those portions rate of change is going to be constant. So if we analyze this first part, here it is positive, and the value is, it changes from -3 to 0. So the rate of change will be so this is -3 x value, this is -2. So in this part, it rises 3 units for 1 unit of x. So the slope is 3 here. So we can say that the rate of change during this portion is 3. So this line corresponds to the rate of change during the first leg. The next leg, it increases from the position minus 2, 0 to 0, 2, right? So change in y is by 2 units and change in x is also 2 units. So basically the rate of change is ratio of change in y to change in x. So it is 1. So we can draw this line at 1 to represent rate of change during this part of the graph. Now here we see that's a horizontal line. Whenever there is a horizontal line, change in y value is 0. So the rate of change has to be 0. So that straight line from 0 to 2 represents the rate of change for this particular portion. Now we have a line which is dropping down. Going downwards means a negative rate of change. The slope is negative. Change in height is of 2 units, which is minus 2 units as we go down for 1 unit of x. So it is minus 2. So from here to here we can draw one straight line showing a constant rate of change of minus 2 in the interval from 2 to 3. Right? So these steps provide us with the rate of change of the given function. So I hope with this you understand how to sketch rate of change for a given function, right? Here the values were clearly mentioned, so we could easily calculate change in y divided by change in x to get the rate of change, right? And those were the values which we plotted. Now in this particular graph, what you need to do is draw your tangents and then find change in height and change in rise over run to get the slope. Those will give you different points and lead to the parabola as I have shown you. I hope that helps. Thank you.